In a previous lesson, we've seen that to organize data collected, we use a frequency table. Then to present the data collected, we can use for discrete data a bar graph, a frequency line graph, an increasing line graph, and a pie chart. So in this lesson, we are going to use the exact same example to calculate central values of discrete data and what they mean for the dataset. I will first consider a number line with the scores at the scale and stack our data points based on the frequency of each score. The first central value we will look into is the mean, which is the average of the data values. Listing our data values, I start by adding them, then I divide them by the total data points, which is how averages are normally calculated. However, listing them and finding their average this way is not practical, especially for large data sets. How can we then use our frequency table for that purpose? Let us compare the sum we have with our table. We notice that 2 is added to itself 7 times, where in the table, this is equivalent to taking the score of 2 with its frequency and multiplying them. And the same is valid for 3, which is added to itself 8 times. So in the table, I take 2 times 7 and add it to 3 times 8, and so on. And then eventually divide by the total. So to find the mean, denoted by x bar, I add the product of the variable values by their frequencies and then divide by the total, which is 30 in this case, which yields a mean of 4.23 for this data set. Now let's mark the mean on the number line. Now our second data value is the median, which is the value at the center of the data set. Listing again the data values, but most importantly in increasing order, as for the median, the order matters. Starting from both ends, we locate two values at the center of the data set, which in this case are 3 and 5. We ended up with two values at the center, as for this data set, the total 30 is even. Had the total been odd, we end up with one value at the center, where that value would be the median of the distribution. While with an even total and two values at the center, the median would be the average of those two values. Again, listing the values is not a practical way to find the median. We again need to use our frequency table. The median being at the center, thus 50% of the data values come before it and 50% after it, we start by dividing the total by 2, which in this case would give 15. As the total is even, I know I have two values at the center that I need to average. As the total over 2 yields 15, then the median is the average of the 15th and the 16th term in the data set. But how do we find those 15th and 16th terms from our frequency table? For that purpose, let's bring back the cumulative frequency column. A cumulative frequency of 7 means we have the first till the 7th term equal to 2. The next cumulative frequency of 15 means the 8th till the 15th term are equal to 3. The next cumulative frequency of 20 means the 16th term till the 20th term are equal to 5. So the 15th term is 3 and the 16th term is 5. Then the median is the average of 3 and 5, which is 4. Had the total been odd, for example 29, 29 over 2 yields 14.5. So the median would only be the 15th term. Knowing that for an odd total, we have exactly one value at the center. So the 14.5 would be rounded up to 15 to find the median. Now let's mark the found median on the number line. Our third central value is the mode, which is the data value that mostly occurs in the data set. Listing again our data set, we notice that 3 is the value that occurred the most, where in our frequency table, we find it in reference to the highest frequency. Then the mode would be the score of 3. Let's mark the mode on the number line. Looking at the number line where we marked the median, mean, and mode, let's look into what these values mean for the dataset. Suppose we rearrange the data values to be symmetrical around the center, having the least number of data points at the ends and the majority at the center. In this case, the three central values would be equal and the data points would be normally distributed, forming a bell curve representing the normal distribution of points around the central values, with the data being rare at the ends and the majority clustered at the center. For a non-normal distribution of points, the distribution could be skewed to the right, shifting the mean to the right with the median smaller than the mean and the mode smaller than the median, while the distribution could be skewed left, shifting the mean to the left with the median greater than the mean and the mode greater than the median. Going back to our distribution, we notice the mean is at the right, slightly greater than the median, which indicates a very slight skew to the right, the mean being at the right side of the other central values. Now that we covered the central values, what they mean, and how to calculate them, in our next lesson, we will look at the measures of dispersion, which study how the data is spread around the central values.